All right, so this is section 9.4 on vectors. And what I want you to keep in mind about vectors is they have both length and direction. So if you look up top, it says length and direction. So hopefully you can see how maybe this is going to start turning into some airplane things, some vectors. Maybe you've done them in physics, but we'll go through them as though you haven't done them yet, so don't worry too much about that. All right, the very first thing we're going to talk about is just graphing vectors to see which direction they're going, how long they are, and that kind of thing. So if you look at this first example, you see vector v up here. We have a u and a w. So maybe you talk about a plane going, I don't know, northwest, northeast, southwest, that kind of thing. Now, the first example says, take vector v and add it to w. Okay, so if we're going to do that over here, you recreate v first. You always start with the first one. So if I look at v, it starts at the point 2, 3, so 2, 3, okay, and it goes up to the point 1, 5, so 1, 5. So you recreate the vector, and you'd have graph paper for this on a quiz. Then we're going to take w. Okay, look where w is. It's way down here at negative 2, 2. Now you don't do it in the same quadrant. You actually start it at the end of v. Now in physics you might be saying things like head to tail, that kind of thing. Let's just say from the end of v. So I'm going to start w up here at the point 1, 5. And then if you look at w and talk about its slope, it has a slope of positive, like down 1 over 1 kind of thing. So if I do that from this point in red, and I go down 1 over 1, here I am at the point 0, 4. Oops. And then I connect it like this. Okay, so now you can see the blue and then to the red, and then if I want to know what actually v plus w looks like, then I actually connect the beginning of v, so the beginning of blue, to the end of w. So I go like this. Oops, is it drawing? So this green in here, that's a little bit messy, I know, would be v plus w, okay? Now the only other one I'm going to do here in the video is number 2, and then I'll save 3 and 4 for class. Okay, so this time it's v minus w. Okay, so same thing, start with v. So I start at the point 2, 3, and I end at the point 1, 5. So here is v, okay? Now, if I were doing w and it were positive, it would look like number 1. Now think about this. Negative vectors are kind of like what we've been talking about this whole time. It's going to go the opposite of what it originally did. So instead of going kind of down and over, now I'm going to go up and over. So negative w would start at the end of v and then go up and over in the opposite direction. So that would be v minus w. Now again, that's not the final answer. The final answer is actually connecting the beginning of v to the end of this v minus w. Or sorry, at the end of this negative w. So I would label this green guy v minus w. Okay, so again, let's hold 3 and 4 off until class. Okay, the next thing we're going to talk about is component form of different vectors. Now this next little bit is a lot of vocab, so please make sure you listen carefully to what I'm saying, because on a quiz or test I won't explain it when you say, what's the position vector, what's component form? So first things first, if I give you 2 points, so look at number 5 for instance, here are my 2 points. And I want to know the position vector that connects these 2 points. Well, you can see up top, the formula itself is not real tough. It's just your x's subtracted and your y's subtracted. All right? And then what I want to say is component form, right here, has i's and j's in it. And it pretty much means the horizontal component and the vertical component. So if I name a vector, I want to know how much over on the x's horizontally, how much up on the y's vertically. Now what's a little bit tricky about this is if you think back to when we did imaginary numbers in the last section. Okay, so in the last section, the I was the y-axis, right? So this is from 9.3. The I was the y-axis. Now in 9.4, we're going to mix you up a little bit. In 9.4, when I say i's and j's, unfortunately, it's actually the I is the x and the j is the y. Now, I didn't come up with that. Don't blame me. I'm just the messenger. But just kind of when you're studying, 9.3, I is the y-axis. Unfortunately, 9.4, I is the x-axis. Okay? Now, let's jump into this question. It says, here's 2 points, P1, P2. Find me the position vector, P1, P2, if here are the coordinates. Now, if you look up top, the position vector, the formula is not bad. You just take your x's and you subtract them. Okay, so x2 is 4, minus x1 becomes positive 1, and then comma, y2 is 6, minus y1. So the position vector itself isn't bad. It's 5, 4, right? Now, if I want it in component form, meaning the horizontal component and the vertical component with i's and j's, here's what I would like to see on a quiz. It is 5 in the I, horizontal direction, and 4 in the j. All right, so that's position vector in component form. All right, now you guys please try number 6. So don't leave it blank. Please give it a shot, and we'll check it in class, okay? All right, now the next thing we're going to talk about is magnitude of vector or length of the vector. Now, even though the notation looks a little fancy, right? So it looks right here. Magnitude of the vector is a double bars kind of thing. It's actually just Pythagorean theorem. So when I say a squared plus b squared under the root, that's just your x squared and your y squared. And then you take the root of it, you get the hypotenuse. So it's the same thing we've been doing. We're just going to give it kind of a new notation with the double bars now. Okay, and we'll do that in part C in just a minute. But if we're adding and subtracting vectors, v and w, for instance, in number 7, all you're doing is combining the x coordinates and the y coordinates, and the I components and the j components. So v plus w for number 7 would just be 2 plus the 3 i's, right? So it's the 2i plus the 3i, and then 3 minus the 4 j's. So I would write it as 5i minus j, right? So there's no real magic to that one. And then if I look at part B, 2 v's, so if I said 2 times the v vector, I would get 4 i's plus 6 j's, and then minus 3 times the w would be 9 i's minus 12 j's. Okay, so I just tripled the w's and I doubled the v's, and now I do my subtractions. So it'd be 4i minus 9i is negative 5i. 6i minus the negative becomes positive 18j's. Now on these two, if on a quiz or test I asked for component form, that looks awesome. You could also express it like this, 5, negative 1. You could also express this as negative 5, 18. Same thing. Now for magnitude v, all you're doing is Pythagorean theorem. So if I did Pythagorean theorem with v, which is 2i plus 3j, I would get root 13. And then for w, if I did the same thing, I'd get 5. So if you need to see that in class, let me know, but I think the Pythagorean you'd probably be okay with. Now, as I said earlier, this section's a lot of vocab, so the next thing we're going to talk about is the unit vector, or the vector with magnitude 1, meaning the hypotenuse is 1, in the same direction as whatever vector I give you. So if you look at number 7, for instance, number 8, if I were to draw this out just to get a visual of what's happening here, if I say 4 i's, that means 4 in the horizontal direction, and negative 3 j's, that's negative 3 in the y direction, I would say my vector looks something like this. And the hypotenuse, you probably noticed already, it's a 3, 4, 5, would be 5. So in other words, magnitude v for this question is 5. All right, so if that's v all mapped out with the magnitude labeled, now I want to know, I want a unit vector, 1 unit long, in the same direction. So just a visual would be like this. If I go over top of the hypotenuse, instead of length 5, what if I just sketch in what would be about 1 length, right? Okay, so I want to know what are the components of that red vector that I just drew. All right, now there's 2 ways to do these. I want to show you kind of a way that doesn't make you memorize a new formula, and then I will show you the way to use the new formula. Okay, so if I want a triangle with that 1 unit on the hypotenuse, we go back to our geometry skills into similar triangles Okay, so think about this, right angle, right angle. These little triangles, the big one and the one inside, are similar. Okay, so if I did something like this, the x value of the big triangle over the hypotenuse equals the x value of the small triangle over the hypotenuse. Then a little cross multiplying and you can see, oh, x is 4/5. So now I know the x component. And if I do the same thing with the y's, it would go -3 in the y's over the hypotenuse equals some y over the hypotenuse. And I get y to be -3/5. So with very little work at all and just remembering a little geometry, you can see the unit vector would be 4/5 I minus 3/5 j. All right, so that's doing it without knowing any new material. Now if I come over here and I kind of point to this formula up here, the formula says the unit vector is the vector itself over the magnitude of the vector. Okay, so let's see how that would look. Unit vector is, the vector itself is 4I minus 3j. The magnitude of the vector is 5. And then take a look, just a little bit of cleaning up, separate it up, I get the exact same thing that I got before. And it's just, a step or two shorter. So it doesn't matter how you do it, take your pick. Now I want you guys to try number 9, and the same thing as number 6. Please don't leave it blank. Please give it a shot. All right, the last page of this video is just a tad trickier. It's not terrible, but I do want to wait for class to do it. So leave 10 through 13 blank for now.